So today we're trying to find the forces in a three-charge system, which is question 10 from the ungraded practice problem. Consider 2-point charges located on the x-axis. One charge having a charge of negative 16 nanocoulombs is located at the position negative 1.74 meters, and the second charge with a charge of 40 nanocoulombs is located at the origin. So we're trying to find the x components of the net force exerted by these two charges on the third charge.
So here is the diagram for our system. We have our three charges, Q1, Q2, and Q3. And we're given in the question that Q1 is located at negative 1.740 meters, and that Q3 is located at negative 1.170 meters. And so we were able to find the distances between each of the charges. The distance between Q1 and Q3 is 0.57 meters. The distance between Q3 and Q2 is 1.170 meters. And the distance between Q1 and Q2 is 1.74 meters. The given variables in this question are the three charges. Q1 has a charge of negative 16 nanocoulombs. Q2 has a charge of 40.0 nanocoulombs, and Q3 has a charge of 45.5 nanocoulombs.
Okay, so next we use Coulomb's law to calculate the force that Q1 and Q2 exert on charge Q3. And that is equal to K absolute value Q1, Q3, Q1 times 2 Q3 over the distance between charge 1 and charge 3 squared. We first need to find the value of K, which we calculate to be 8.99 times 10 to the power of 9. And plugging all of our given values, Q1, Q3, and K, and our calculated value, the distance between 1 and 3, into the equation, we get a magnitude of a force of 2.014 times 10 to the power of negative 5 newtons. And when we account for the fact that Q1 and Q3 are opposite charges, that means that Q1 has an attractive force exerted onto Q3, and so the force that Q1 exerts on Q3 is to the left, and so we apply the vector to the force, and so we get a final force of negative 2.014 times 10 to the power of negative 5 newtons.
Then we can use the same method, Coulomb's law, to calculate the force between Q2 and Q3, but this time it is a little bit different. Q2 and Q3 is the same charge, so they have repelling forces between each other. So the final answer the final force between Q2 and Q3 is equal to negative 1.195 multiple 10 to the power of negative 5 Newton.
So as the final step, we would add the forces exerted by charge 1 and 2 on charge 3 together. And then we get a final answer of negative 3.21 times 10 to the power of negative 5 newtons as our final answer, keeping 3 sigma.